It has visual modules for creating, executing, and optimizing SQL queries, for designing, modeling, generating databases, and for configuring servers, administering users, and viewing database health. MySQL Workbench is available for Microsoft Windows, Linux, and Mac OS X on 32-bit and 64-bit systems. There are two editions, the Community Edition, which is freely available from mysql.com, and the Standard Edition, a commercial version that builds on the Community Edition by adding enterprise features such as schema and model validation and the generation of database model documentation. The Home tab is the starting point for working with Workbench. It contains three main modules: SQL development for working with queries, table data, and scripts, data modeling for designing database models and diagrams, and server administration for monitoring, securing, and configuring your servers. To use the SQL development module, create a new connection to a server instance or use an existing one. In Windows, Workbench detects if you've got MySQL on your local machine and creates connections if you have. To create a new connection, click New Connection and enter the server details. The hostname and port identify the server instance you want to connect to, and the default schema indicates the active database when the session opens, useful if you frequently connect to the same database. You can also set per connection options, for example, to enable compression over networked connections. While it's possible to save your password with each connection, you might consider it more secure to enter the password each time you connect. You can work with all of your stored connections with the Manage Connections dialog that displays all connections along with their settings, useful if you connect to several MySQL instances and databases across your network. You can also create new connections from this dialog using the same settings as you have already seen. Double-click a connection to open the SQL Editor tab. You will need to enter your password if you have not saved it with the connection. The SQL Editor contains a query pane for typing and executing queries, a SQL Additions pane for containing SQL statements, an output pane, and an object browser for displaying metadata. The outer panes can be hidden if you wish. Queries are executed against the default database, chosen by the connection or by double-clicking the schema. After selecting a database, you can execute statements against that database. The editor pane highlights the syntax of your statements as you type. Execute your statements by using the query menu, toolbar icons, or if you prefer, shortcut keys. You can write as many statements as you like in the editor, for example, to save as a script. If you have multiple statements in the editor, you can execute all statements together or execute only the statement under the cursor. The toolbar contains icons to execute the current statement or the whole contents of the editor. When you execute multiple queries together, each query generates its own results tab. The object browser shows schemas and their structural contents, and lets you see the object information for databases, tables, columns, and other objects. If you click a table, it shows summary information for that table. You can expand the list of tables to see additional metadata. By clicking on any of the columns listed, you can see that column's information. The browser also shows other structural information, such as any indexes attached to the table, and the names and definitions of any foreign keys. One very powerful feature allows you to generate the create statements for objects such as tables and stored routines, placing them into an editor so that you can view or modify the object. The editor has other features that are useful to database professionals. Many statements are longer than a line or two, and to make statements such as this one easier to work with, you can use the editor to reformat the statement. There is even a plugin to make all keywords in the statement uppercase to go along with the most common SQL conventions. On the right of the editor, you can view the SQL Additions pane. You can add snippets of code to this pane by clicking on the toolbar icon. You can view these snippets, edit them, and execute them at a later stage. As well as your own snippets, the SQL Additions pane contains many useful fragments of SQL syntax. For database management, various show statements. In the DDL category, various create, alter, and drop statements. and in the DML category, statements for querying and modifying data. Each snippet contains detailed syntax for each statement, including the various optional items. As with your own snippets, you can insert the stored code fragment into the editor at any time. The output pane records statements that you have executed, along with information on rows returned and duration. You can copy statements from the output pane to the editor to edit or re-execute them. If you have saved your own snippets to the SQL Additions pane, you can re-execute them more easily. MySQL Workbench lets you edit data in various ways. Obviously, you can execute insert or update statements in the editor, but you can also edit data directly in the results of certain queries. In this case, the results pane shows the result of a query that aggregates data, so the result is marked read only. If instead we issue a query that doesn't aggregate and also includes a unique identifier such as a primary key in its column list, the result table for that query is editable. To edit any value, double-click on it and you can edit it in place. Once you have completed your edits, click Apply. Workbench displays the update statement that performs the edit in a dialog, which you can then apply to the underlying table. You can also modify data in a similar way by right-clicking a table in the object browser and by selecting Edit Table Data. Going back to the Home tab, the Data Modeling module lets you work with enhanced entity relationship models. You can create a model of an existing database by reverse engineering it. To do that, connect to the server by specifying a stored connection in the usual way and choose the database you want to reverse engineer. The wizard retrieves all object information for that database and lets you choose which objects you want to reverse engineer. You can also choose to place all the imported objects on a diagram at the beginning. To start with, the objects are clumped together in the middle of the diagram, but we'll come back to that in a moment. The model contains a new schema for the reverse engineered database, along with an empty schema which I will now delete. Each model can have multiple diagrams, which you can name as you wish. As you see, the objects in the model are shown in the diagram, but you'll need to arrange them before making any sense of them all and how they're related. The Sequela diagram has more tables and views than can fit comfortably on this screen. You can use the bird's eye view to drag the viewport around the diagram, or you can zoom in and out to view the diagram at whatever level of detail you want. The objects in the diagram, such as this actor table, can be modified in several ways. For example, you can change the color of each object, either to make it stand out in the diagram or perhaps to group related objects together. You can also edit the table's metadata directly from the diagram. In this case, I'm changing the size of the last name column from 45 to 60 characters. Back in the model, you can see that the metadata of the actor table has changed. Because this model was reverse engineered from an existing database, you can synchronize with that database to make any changes you've made to the model apply to the underlying database. As before, choose the connection to use and enter the password if required. The wizard connects and retrieves the current state of the database and compares it to the model. Here, it shows that the actor table has changed and displays the statement needed to make that change. Executing that statement brings the database back in sync with the model. Another useful feature of this module is the ability to forward engineer a database. You can imagine creating a model in this tool and using it to create the underlying database without having to write all of the create table statements yourself. To simulate this, if you change the name of the schema, it now models a database that doesn't exist on the server. To forward engineer the model, connect to the server as before. Validating the model ensures that Workbench knows what statements to execute. In this case, it needs to create the Sequela new database. You also have the option to fine-tune the new database in a number of ways and to choose which objects to export. You can save the script to a file, copy it to a clipboard, or execute it straight from the wizard. Once you've completed the wizard, you now have a new database that contains all the objects and relationships in the model. To see the new database, go back into the SQL editor, display the object browser pane, and refresh it to get the latest metadata from the server. The forward-engineered database appears. For a database with many tables, you might want to create several diagrams, each one showing only a subset of objects in the database. In the Sequila database, for example, customer address information is stored in the address table, linked to the customer table. Addresses are then linked to cities in the city table and onward to countries in the country table. Having created the diagram, you can rename it to reflect its contents. Once you've created the model, you can save it as an MWB file, which you can share with others. Saving that MWB file also makes it appear in the Home tab as a stored model. Because reverse engineering a database is so common, there's a shortcut to do it straight from the home screen. Here, I'm reverse engineering the World InnoDB database using the same techniques as before. The Sequila database comes with a sample EER model that you can load into Workbench. The sample model demonstrates many features, including the ability to lay out the diagram with layers and colors, making the model easier to use. The third module is for server administration. It contains features for monitoring and configuring your server. The Server Status screen has graphs for various system and MySQL metrics, along with a list of connections and their status. You can start and stop an instance from within Workbench, and you can view the status and system variables of the running server, whether all together in a single list or categorized per function within the server. You can view server log files, including error logs, binary logs, and InnoDB logs if configured from within this window. Startup options are shown in a multi-tabbed window. The options that currently apply to the server are shown with their current values, and you can change those options within this window. They are categorized per function, and any changes you make are saved to the configuration file you specify, where they will be read the next time MySQL starts. You can configure users, their roles within the server, and other privileges. Finally, you can export and import data directly from within Workbench. Specify the folder path, and it exports each table to a separate file in that location. Alternatively, you can export to a single file. Choose the database you want to export, and optionally choose individual tables. The export process requires a password and displays its progress. As you can see, each table is exported into its own file. The import process reads the folder path and displays database objects and tables from that location. So there you have it. That's Workbench along with its 3 modules: SQL development, data modeling, and server administration. Wow.